double review period to give you guys some time to work on your choice assignment. Maybe do a graph. And maybe do some more word problems to see how things go. But I think we're going to probably do, rather than 3 days of word problems, we'll probably do 2 days of word problems, and then we'll see how Friday goes. If the word problems are still difficult, I can do more on Friday. If not, then we can sort of call it a unit at that point, and give you guys some time to work, okay? And Bailey, I will let you know so that you can know what's going on for Friday, okay? All right, here we go. Today's lesson is called Optimization Word Problems. All right, just sort of slow down here before we start. When I say optimization, when I say max or min, what are you hopefully thinking in your brain? When you hear, you're with me here, stay with me here, please. When you hear optimum or max or min, what are you thinking? Sorry, Jack, let's somebody else. Nathan, go. Very good. So we're looking for most of these problems, slope equals 0, so f prime of x is going to equal 0. Okay? And that's generally what's going to happen. We'll normally have domains and ranges and stuff like that in there. So this will be, remember that question we had, can I just take a minute? Do you remember that question that we had earlier with the box that was folded up? Do you remember that? I don't know if you remember, we did that earlier. We had a box that was folded up on all sides. So there'll be stuff like that will be in here, right? Okay? So here we go, example 1. A rectangular field is to be enclosed using 300 meters of fencing along 3 sides. Side being a natural embankment. That's $25. Determine the dimensions to maximize area. Okay, this question probably you saw in your grade 11 class. You might have seen this one. All right, maybe not, maybe not. Okay, we're solving it though with calculus. Okay, so we're going to do it with calculus because maximum, anything that's a quadratic, you can solve with grade 10 or grade 11 methods. Okay, so what does that mean? 3 sides and 4th are natural embankments. Sorry, go ahead.
What's that word?
Embankment.
Okay.
What I basically mean is this: assume you have a house or something like this, or a lake or something. Okay, you only bring the fence on 3 sides. So that's what we're saying for that. Okay? So it's going to be a lake or a whatever, a house. Think of that, you have your house, you don't have to do a fence on the side of the house. Okay, what is my, the tricky part about these equations are going to be you're not actually getting an equation you got to solve. You have to make up the equation yourself. That's the thing that's going to be tricky. We'll give you guys so many examples, you'll feel good about this, I hope. Let's start with my equation that I'm trying to maximize, which is area. What is the equation for the area of a rectangle, please? Right, Derek. Thank you to the rest of the class and Derek. Guys, we got to be awake here, please. Length times width. Good. Tanner, I hope you knew that. Okay, good. Okay. So I'm going to say area is length times width. So I'm going to just call that length. I'm going to call that width, if that's okay. All right. All right. Keep going here. Area is length times width. What's the problem when I just try and maximize that? If I were to say maximize that, take the derivative of that equation. What's the problem? Yes? Well, more than that, I have 2 variables, right? I have a length and a width variable, so I can't just take the derivative of it. So what I'm going to do is I'm going to use my perimeter to get this to work. What's the equation for perimeter in this case? Go ahead.
2 length plus 2 width.
Yeah, so my perimeter, not 2 length plus 2 width in this case.
Length plus width on those things.
Yeah, good. So I'm gonna call it 2L plus W. Okay. What is my perimeter actually equal in this case? What's my perimeter gonna be? 300. 300. Whoops. Okay, so now what I have two equations. So I'm gonna isolate W, so you only have one variable.
That's a 2L.
2L, sorry, yes, 2L. Sorry, I'm sorry. Isolate, sorry, I will next time.
Because that's
So you only have one variable in your area. Okay, and this is the key to all of these questions, okay? You only want it so that when you deal with your area, I can't take a derivative yet with two variables in it, right? So that's the problem. So what I'm going to do is I'm going to substitute here so I can end up with one variable. Does it sort of make sense, the concept what I'm trying to do here? Cal, I know grade 11 was a long time ago for you. No offense.
Sorry, is that times where there's 1 times
It's all good. So it's all good. It's all good.
Is the length of the side 1?
No. Is that better? Are we all clear now? We're all somewhat clear, yes? Okay, but the idea here is that we can hopefully see now that if the area, I had two variables, I'm going to have one now. Can somebody tell me what to write to get down to only one variable? Area equals what now? Let's go ahead.
No, I'm good.
You sure?
Yeah, I don't know.
Okay.
My mind is blank.
Yeah, go ahead.
Couldn't you like W and
Yeah.
then
So I'm going to say W equals 300 minus 2L. Now, there will be one of you in this class, let's call him Derek, okay? Derek would try to isolate L here instead of W. Derek, why is it bad to isolate L in this question?
There's only one W and there's 2 L's.
Yeah, you'd end up with fractions. Now, you can still do that. You'll still get the right answer, Derek, so don't but the problem is your derivatives will be holding it, and that's where everything's going to be worse because of the fraction. So what does this make my area? Let's go.
Length plus 300 minus 2.
Close. Times instead of plus. Okay. Now this is a lot easier for me to deal with because I only have one variable. So everyone see what I did there with that in between step? James, sort of? That in between step, you see why we have to do that? Okay. All right, now I can follow that out or I can use product rule. What do you guys prefer? I can follow that out and use product rule. Emma, what would you have to do? Follow it out, sounds good to me. So I'm going to say my area equals 300L minus 2L squared. All right, Luke Chase on. Can you be brave and take the derivative? It's derivative of 300L. 8 prime. And the derivative of negative 2L squared is?
4L.
Yeah, good, minus 4L. I know what you're saying, man, this unit is so much easier than the last one, okay? Because that is easy compared to the last ones that we did. All right, now this is the key to these questions to finish up. I found A prime, great. Okay, I didn't know what to do with this question, so I decided to find A prime. Why did I find A prime? Sorry, go ahead.
Because if you want to find the maximum area, you have to set A prime to equal 0.
Good. So my maximum is A prime is equal to 0. So I'm just solving then 0 equals 300 minus 4L. 4L equals 300 and L equals 75. Okay. Then back into here, my width then equals, what's my width? Therefore, the optimum area is 75 by 150. Now have some mean grade 11 teachers. Give this one in grade 11, okay, but this one's tricky because you have to make up your equation. That's what you're going to find in all of these. I'm confident in you guys, you can do these. We'll do lots and lots of examples, okay. I might print out for you guys, hopefully you're not embarrassed. Remember that grade 9 formula sheet you guys had with volume and surface area and all that stuff?
From grade 9?
For EKO, I'm going to print one out, I think, for you guys. Because a lot of this stuff will involve area and volume and, you know. Okay, so just, you guys can have that for your test, you'll get it. So, but if you're freezing, you see, you can't remember the volume of a sphere, I can probably give it to you without freaking out too badly. Okay?
Please.
I'm going to hit, which one's a sphere? I'm going to down 100%, I'm giving you a sphere. This is calculus. Okay? I'm going to hit pause on the video. You guys can take a deep breath, and then I'm going to write the next question on the board.
Yeah,
Oops.